Our last vegetation talk is by Jules Evens, and she is the director of California Native Plant Society Vegetation Program, in which she supervises a vibrant team of ecologists and collaborates with state, local, and federal agencies on the classification, mapping, and monitoring of vegetation projects across California, including the Greater Bay Area. She's co-written a manual of California vegetation in 2009 and a California Botanical Landscapes, a pictorial view of the state's vegetation, and has co-published various journals, books, chapters, reports about the diversity of California's habitat and vegetation. Her talk is Fine-Scale Vegetation Mapping and Inventory Across the Greater San Francisco Bay Area, California, with a focus on Alameda and Contra Costa counties. Welcome, Julie.
All right, I get to be the wrap-up here. First, I want to just thank a variety of collaborators for the talk I'll be giving. I think maybe I got the longest title, so I don't know, maybe I should have shortened mine too. First, I want to just thank my colleagues at the California Native Plant Society, including Mark Bibbo, also Golden Gate National Parks Conservancy, Danny Franco, East Bay Regional Parks, Dina Robertson, and Tukman Geospatial, Mark Tukman. We work collaboratively on the projects that we do, including in Alameda, Contra Costa, but in any of the areas that's been talked about today. And also just I want to thank a variety of others that have contributed either time or photographs to the talk. So in general, fine-scale vegetation mapping, as what Rochelle was talking about earlier, we've been working kind of in lockstep. Over the last, I guess you could say around decade, we started in Sonoma County with a collaborative project with Tukman Geospatial to map that area starting in 2013-14 and finishing up in 2017. As that finished up, the work then started in Marin, San Mateo counties and part of the small part of San Francisco counties in a couple of year time frame, and just recently completed a project in Santa Clara and Santa Cruz counties. And this past year and then ongoing, we are working both in Alameda, Contra Costa counties, as well as Monterey, San Benito, and San Luis Obispo counties. And the work that we're doing is countywide vegetation mapping, as well as wildland fire fuels and forest analysis. And why are we doing this work? Well, as you can tell from some of the talks just here with the variety of climate variability we have from coastal to inland, our ecosystems are quite diverse, our topography is quite diverse, and also the variation of natural, semi-natural, and then on into developed areas. We need information, whether it be the general public, land owners and managers and agencies, to know what the locations and distribution of natural resources across the landscape. In these projects that we're doing, as we work across them, it's always a discovery, even in areas that we thought we knew a lot about them. We're continuing to fill in knowledge gaps, whether it be the Greater Bay Area or beyond. And usually what we're starting with is piecemeal vegetation maps, some of which that can be either outdated or they're inconsistent. They don't really denote what the biodiversity is. And so this work, otherwise, managers who are using inconsistent maps, they're relying on those, and then they're making poor land management decisions. So an example of this, of an inappropriate scale for local planning, this is an example of a statewide fuels map on the left-hand side, and on the right-hand side, a fine-scale resulting map in our most recent project that has been completed in Santa Cruz County. This work by Tukman Geospatial and others is to show the improvement of a statewide data set for wildland fire fuels that then can guide restoration and land management planning, and that newer on the right-hand side 5-meter fine-scale fuels map can help better denote where there can be prioritization of such things as prescribed fire or other techniques to foster resiliency in the landscape, especially in the wild and urban interface. Also, we are starting often with coarse or outdated vegetation data on the left-hand side showing a statewide vegetation map from CalVeg, and on the right a fine-scale vegetation map, and this being in Sonoma County, where you can kind of just see the, while both were alliance-level maps, on the right-hand side, on the left-hand side, very coarse, and on the right-hand side, being able to better represent the biodiversity and precise locations for vegetation at a fine enough scale that's useful for local conservation and stewardship efforts. As Rochelle talked about a little bit, this is an integrated process, and a lot of it is getting data on the ground and data for different parts of the modeling and mapping that we're doing. The data that we collect in the California Native Plant Society, where we get on the ground to collect ground-based data to support and analyze data for a classification. There's other data that also gets collected at the same time, whether that be LIDAR, color imagery, and other data sets to output things such as enhanced lifeform maps, and then fine-scale vegetation maps. And the classification information of on the ground that we take then informs other analyses, including the fine-scale vegetation mapping. And this data that we collect in this integrated process is used for conservation and land management planning. The data collection that we use, I wanted to just say, we used kind of usually two, a plot-based technique and a stand-based technique. They all focus on, when we're looking and deciding on what we're sampling, is we want to look at repeated patterning in the landscape. And as we look at that repeated patterning in the landscape because of certain site history and environmental characteristics, we're always looking at the species composition and that repeating species composition, and we're also looking at abundance of species in the landscape, whether it be more of one herbaceous community or another of assemblaging in the landscape. And then in general, whether it be a plot-based, where we're looking at a full vascular plant list, or when we do our rapid assessments, it's when we know more about that vegetation type and we just want to get repeatability in the landscape, and we're collecting a lot more surveys when we can do the plotless stand-based techniques. And all of this information of plot-based vegetation sampling, we're getting surveys of vegetation types to define associations, this lowest part of the National Vegetation Classification. So this is just an example of an alliance and associations within. We more recently, in the last few years, we've been combining alliances. So we used to have a Hesperocyprus argentii and a Hesperocyprus magnabiana alliance. They've been combined into one, and then that variation is at the association level. And so taxonomy for species and taxonomy for vegetation changes over time based on a variety of factors, but our data collection and looking at things like the environmental setting that these plant communities are occurring, and then the associated species. Both Macnab cypress and Sargent cypress can have similar vegetation in the understory, whether that be white-leaf manzanita as one of them as an example, or other manzanitas and ceanothus species, and then serpentine defining where or other ultramafic surfaces for defining that alliance. This National Vegetation Classification that we adhere to, whether it be the lower level and then on up in grouping, you have the middle levels and the upper levels. And then all vegetation that we're classifying kind of has a grouping like this in our National Vegetation Classification system. In the most recent vegetation work that we've done in Santa Clara, Santa Cruz that just got published, that work is accessible in a variety of formats, including through Tukman Geospatial's webpage, through pacificvegmap.org, as well, and Rochelle showed the others, including BIOS and our vegetation websites, both at CNPS and the Department of Fish and Wildlife's VegCamp website. In general, we've collected all this data, and then what do we do with it? We put it into project reports. This is being a 2-county project report for Santa Clara and Santa Cruz that's now available, where we've collected all that vegetation data, we're informing a classification, and then we've prepared a report that describes and keys out the vegetation community types and has a set of descriptions. So this being the example of one of the many descriptions where it talks about the plant communities and then where they're found. The vegetation classification, and this is the key, just showing kind of like a dichotomous key from Santa Cruz and Santa Clara County. So the vegetation classification of points on the map then informs a fine-scale vegetation map, and a map is usually at the alliance level for the woody vegetation types, and for herbaceous plant communities, it's often quite hard with the imagery that we have and the funding that's provided to do mapping for herbaceous plant communities at the alliance level, so it's usually at a higher level grouping in that NVC, the National Vegetation Classification that I showed just before. But in general, these fine-scale maps are produced, and they're produced by color imagery, LIDAR, the vegetation keys and classifications that I showed. But also what results is a variety of other projects, at least in the Greater Bay Area. The Greater Bay Area's work, including Santa Cruz, Santa Clara, as well as other areas, there is information from other data sets that are being analyzed to provide other information as well. But in general, this fine-scale vegetation map that gets produced also then gets assessed for accuracy through an accuracy assessment to determine that it meets a certain level of accuracy so it can be relied upon to be a valid map. Oh, go back. Oh, gosh. Oh, there we go. So one of the other data sets that's used heavily to produce the fine-scale vegetation map is LIDAR, and it gets analyzed for a variety of other pieces of information to create GIS layers. They include canopy height, canopy base height, bulk density, canopy cover, and then ladder fuels. This type of information gets analyzed to assist in a variety of other data sets that get produced, and one of that being assisting in fire fuels modeling. And on the upper left shows a complicated process that basically is undertaken by taking the LIDAR and the stacked variables that I just showed in the previous map, and the stacked variables produce what's called an enhanced lifeform map, which is in the upper right. So that could be herbaceous, it could be woody riparian, treed woody riparian, or shrubland riparian, or shrubland upland, that type of thing for enhanced life form. And then it also shows things like the ladder fuels, and then produces a fine-scale map. The projects across the Greater Bay Area that we've been working in, to inform our statewide vegetation classification, I'm going to go a little bit into detail to show some of the more recent information defining plant communities. The first being Marin and San Mateo County. This has been a project in collaboration with TAM and Golden Gate National Parks Conservancy, with a goal of mapping 800,000 acres and to do wildland fire fuels mapping, as well as classification and description of vegetation community types. Some of the most recent natural communities to come out of Marin and San Mateo counties, this includes a new alliance right along the coastal bluffs of Eriophyllum staccatifolium, Erigeron glaucus, and Eriogonum latifolium, a very colorful plant community in the upper left here, with a variety of associations that might have already been defined before or that have been more recently defined over the last 5 years. Another association is in the bottom right, which is localized just within maritime chaparral of San Mateo County. That includes either Arctocephalus montarensis or Arctocephalus imbricata as either of those defining that association within that localized area of San Mateo County. In Santa Clara and Santa Cruz counties that I was just talking about a little bit of the mapping and modeling, we have completed this project in collaboration with Golden Gate Parks Conservancy and the Santa Cruz Mountain Stewardship, with a host of other collaborating entities. And some of the recently described plant communities include different associations of ponderosa pine. That includes a more open ponderosa pine association with Coryzanthe pungens, and then there's another association that has woody vegetation defined within the ponderosa pine. And then on sandy soils and the sandhills of Santa Cruz, in recent fire areas, there is a association of Lupinus albifrons and/or Lotus scoparius with Coryzanthe pungens in more open, even more open settings than the ponderosa pine. And then another kind of like broader expanded, we've expanded the Quercus wislesinii with Quercus parvula as an alliance. That is a new change. And then the Quercus parvula shrevii association is nested within that. In Alameda, Contra Costa County, which is where we're working right now to define and map the plant communities, this is in collaboration with East Bay Regional Parks and a number of other collaborators, with a goal to map around 900,000 acres. Also to do wildland fuels mapping, and then fine-scale mapping of localized grassland in a pilot that's additionally underway. Here is some of the recently or to be described, yet to be described because the data is just pouring in and we'll be analyzing it this winter. Includes, these are 3 different alliances and then different associations within. One with Viola pedunculata in the upper left, that is recently described. And then in the upper right and then the lower part, those are ones to be described that we think that these are what they will be, is one with leptosiphon ambiguous and one with mixed, whether it be mixed and or ones defined by Lupinus microcarpus or succulentus, more common lupins that are occurring in the landscape. And then a few woody types in Alameda Contra Costa include stands that are in maritime chaparral that either have Arctostaphylos pallida or Andersonii within the Maritime Chaparral Alliance of Arctostaphylos crustacea tomentosa, and then one of Malacothamnus fasciculatus and or other Malacothamnus, and we are defining now and combining different species within a new association in areas that have been recently burned. And then I'm not going to say anything other than as a teaser that we're also working in San Luis Obispo, Monterey, and San Benito counties, where land access is definitely something that we need to, we're continuing in the second year that will be helping us map over 5 million acres of area, and this will include new manzanita associations. And then in general, in summary, we're working in an integrated mapping and repeatable methodology so that areas that we're mapping can be mapped over time in space and time. So as an example, in Sonoma County, now that that map is over 10 years old, they're going to be working to remap that entire area using LIDAR and other information to work on a new map of that area. And, data is key for baseline data and then monitoring over time, and these maps that can be useful with better maps leading to better land management and conservation over time. So thanks, everyone, for listening. One question, anyone? Get off the hook. Oh, got one in the back. Darn, I'm not off the hook.
Hi, will that remapping you're just mentioning in Sonoma include a change analysis?
Yes, definitely, yes. Yeah, and Tukman Geospatial is going to be working with the Sonoma County Ag and Open Space District for that work, so you can ask them about that project.
Thank you very much, Julie. And this is the end of the vegetation session.